Hey everybody, it's Tommy Dunkhouse. We're at the Secondstage workshop today. I'm going to build a turbo manifold, just a K motor in a K30. So pretty straightforward. All you need is a front cut of a K30, Toyota K motor, and we'll get stuck into it. I'll show you what's involved. First step was jump on the computer, draw ourselves up a flange, send it off to the laser cutter. And then they send you back one of these. So that goes onto the motor. And these here are flanges for the turbo. Now, when I get these made on the laser cutter, I get the holes laser cut a touch smaller so that I can drill them to the correct size for what I want. So let's go drill them out. So I've got the holes all drilled out to the correct sizes. These ones tap. Put this aside. Clean the black scale off these parts. So we've got our two flanges here in this jig. So now it's just a matter of connecting them all together with a bit of steam pipe. So I made this up. This serves two purposes. Not only tells me exactly where the turbo flange needs to be in relation to the head flange, it also allows me to tighten this down nice and tight on a really strong flat surface as I weld it up to try and prevent as much flange warpage as possible. So get some steam pipe and connect the dots, like a big puzzle really. So this is what we call steam pipe. It's just a heavy wall bit of pipe. And the reason we use this when we're building turbo manifolds is the way a turbo actually spools, it's not air velocity, it's actually the heat coming out of the engine block. Now that heat produces like a really high pressure. And so what happens is we have a really high pressure inside the manifold, and the dump pipe side of the turbo is a really low pressure. So all that pressure needs to go somewhere. It passes through the turbine, and that's what spools the turbo. So on a smaller engine like a 4K, we're actually really interested in really good spooling, because we're not running 40 PSI on a big drag engine making 1,000 horsepower. We're going to be running 5, possibly 10, maybe a little bit more pressure. And so what we're more focused on is how the turbo comes on rather than flowing massive amounts of air into the little 1.3 litre. So we want to keep the manifold as short as possible, which is why we go for that log style manifold. If we went like a big long spaghetti manifold, the volume in that is much larger, and therefore you don't build as much pressure, so therefore your turbo spools a lot later on. Now on a big drag application, that's not a drama. On a little street K30 for example, we'd way rather have mid-range response out of the turbo rather than making 30 PSI. So we use a thick wall because that holds all the temperature on the inside of the tube. If we have a really thin wall, all that heat just leaks out of the actual manifold, and that heat leaking out of the manifold isn't going through the turbine. It's wasted energy. So you'll see a lot of turbines like this. This is off an SR20. Thin wall. And you can see how long all this is. We have to fill all of that up with high pressure before it will go through the turbine. And then while it's filling up such a massive amount of volume with all these different pipes, because it's thin, all the heat's just leaking out. We're not making great use of the energy leaving the motor. So on a street application, we want it short, we want it sweet, we want it thick. All right, so that's why we use what's commonly known as steam pipe. Let's weld it all together into some sort of manifold. So next step was pretty straightforward. Obviously we've got the tube coming down here, but you need a hole for the exhaust gases to move through. So a hole saw, and then die grinder. Ground all that out. Beautiful. So that's most of the manifold all tacked in place, and we'll get on to the part that heads into the turbo. Let's wait for this fan to finish, Tommy. That's better. Alright, we're really cruising along now. So I've got this part here, and this is going to be my finishing piece that goes in there, but we need that to obviously have a hole in it. Take it out the jig, drill it with a hole saw, and we'll port it out with the die grinder. Woo. So we're fully welded on that part now. As you can see in there, it's blanked off, so we're going to drill a hole and port the rest out with the die grinder. So there we have it. That's the fabricating part of the manifold done. That's the time-consuming part. And if you take your time and you take your effort and all your gaps are right, the welding bit's the fun bit. So now that we're fabricated and we're made, we put quite a few healthy tacks on, and I'll weld as much as possible while it's still in the jig, because I want it to try and stay flat. Problem with welding is we introduce a lot of heat, and when metal gets hot, it tends to bend. So if we leave it in the jig, bolted down at these 4 points here, we'll try our best to keep it flat. So let's get it tacked up and give it a good old weld. Now that we're fully welded up, we're out of the jig. Now it doesn't matter how good your jig is, it doesn't matter how flat you keep it, it's gonna move when you weld it. So from here, it's really important that this face here is nice and dead flat, because that's how it seals to the motor. If it's not flat, you'll have exhaust leaks, and they always suck. So we take it from here, head over to the belt sounder, and we give it a skim on the belt sounder to just make sure we are nice and flat. So after all that, we move on to the dump pipe. So this is the part that I had laser cut. That goes straight onto the back of the turbo, and then we need to turn this into a dump pipe. Now, what I'm trying to achieve here, we made these two bits of material, and they're going to go together somewhat like that. Now what we're trying to achieve here is a nice low pressure, so a lot of volume that creates a low pressure on the other side of the turbine. So we were discussing before about having a high pressure here in the manifold, the turbine sits here in the middle, and then the low pressure. So as that pressure builds, where does it go? It has to go to the low pressure past the turbine into the dump pipe. So 4K motor, 1.3 litres. I'm going to make a dump pipe that's 2.5 inches in diameter. I think that's plenty to let it breathe. And then let's grab the turbo. So here's a T25 turbo. This here's the wastegate. So when you get to your desired pressure of boost, this little gate here opens up and allows exhaust bypass the turbine, and that's how you control how much boost is actually going into the motor. So we need that to be able to escape air as well. So that's sort of what that setup there does. All those exhaust gases, whether they're coming through the turbine or through the wastegate, come through the pipe onto 2.5 inch. So let's get all them welded up. Quick clean up with the grinder, that's what we're left with. So it's a bit of a weird shape, so's that. So we're left with this. Now the reason for this design is one, it's nice and compact, we can fit it in the small Corollas. And two, it leaves us with a massive amount of area for all that high pressure that's coming through the turbine to dump into, hence dump pipe. So we want that as large as we possibly can get it. So there's a nice big area there that will provide a low pressure system for all that pressure to come through the turbine and spin it up nice and quick, get us on boost nice and early for a really good street driven turbo setup. So from there, I'll put a 2.5 inch tube off of it. So the main manifold's finished and we've done the tricky bit of the dump pipe. Now we just got to get this bend on here. So I'm using the front cut here to make sure that all my clearances are all spot on. So let's mark that up and tack it together. Couple of tiny tacks, just do one last test fit to make 100% sure, and then we'll get on with it. So with all the fabrication finished, we need to chuck some paint on. So good paint job starts with good preparation. Wax and grease remover here on both manifolds. And I'm going to paint it in a high temperature paint. So it's good for up to about 800 degrees. Being mild steel manifolds, they will rust straight away. So this keeps them looking nice and fresh. So I've used a silver paint on the dump pipe. I just break it up a bit and make it look nice. So there you go, there's a finished product. Comes with the studs for the turbo and the special nuts for the heat there. It's mounted on the car with all the clearances, and it's actually made to fit the standard manifold. Pretty straightforward. So if you're interested in a product like this, please shoot me an email at secondstagefabrication@outlook. I'll put the link down the bottom. And huge shout out to a vendor as well. These are all his songs on this video, and it's a massive appreciation that I'm able to use his music. So check him out on SoundCloud and enjoy that. Thanks for watching the video. If you liked it, hit the like button. I'd appreciate a subscription, and tell your mates about it. If your mates like rusty Corollas as much as I do, show them some videos, send them to your mother, let your landlord know, all those good things. So I hope everyone's having a great day. Take it easy.